Diabetes and insulin. What is diabetes?
Diabetes mellitus.
Diabetes mellitus is a group of diseases that affects how your body uses glucose or blood sugar. Now, glucose is the sugar that provides energy to the cells in your muscles, tissues, and mainly to your brain. Now, there are two types of diabetes, type 1 and type 2. Now, insulin, the hormone made by the pancreas, which allows the body to use glucose from mainly the carbohydrates found in food for energy and storage for future use. Types of diabetes.
Diabetes.
Now, type 1 diabetes is when the body does not make insulin because of the beta cells located in the pancreas have been destroyed by the immune system that attack those beta cells, resulting in little to no production of insulin. An injection of insulin is needed to process the glucose. And type 2 diabetes is when the blood cells become resistant to insulin and the pancreas is unable to make enough insulin to overcome the resistance, and instead of the glucose moving into the person's cells, it builds up in the bloodstream that causes high blood pressure. It is a progressive condition, which means that the longer the body is injected with insulin, the more it becomes dependent on it, that leads to the patient not being able to stop the injections. Now, in both types of diabetes, type 1 and type 2 can lead to various health problems such as hyperglycemia, that is high blood glucose concentration on more than 2 occasions. While both share symptoms such as excess urination, blurred vision, extreme thirst, lethargy, and excess weight loss, with only difference being that type 1 has these symptoms more aggressively. Glucose.
Sugar.
Keep in mind that glucose is the sugar that provides energy to the cells in the body, with the chemical formula of C6H12O6 and a structure of a carbon chain that is covalently bonded to OH, H, and has a
Bond. Single double bond.
to oxygen. And remember that this relatively rigid structure is when the carbon chain is not in a solution such as water. Glucose is a polar molecule with polar covalent bonds from the carbon-hydrogen bonds, with the carbon having a slightly negative charge and the hydrogen having a slightly positive charge, since the carbon has more control over the hydrogen's electrons. Now, these positive and negative polar bonds, such as the carbon and hydrogen one, creates dipole moments and London dispersion forces, also known as instantaneous dipoles, which is when the electrons are lined up electrostatically directly across from each other to create that polarity. Now on to insulin. Keep in mind that insulin is the hormone made in the pancreas that regulates the storage of glucose and allows it to be broken down into energy, that has a chemical formula of 256, hydrogen 381, nitrogen 65, oxygen 76, and sulfur 6.
C256A3ALMNOP.
A structure that is crystalline solid, that is made of 2 peptide amino acid chains that have a nonpolar and polar sequence that are bonded together by 2 disulfide bonds. It is a prepared homogeneous mixture with other substances, including preservatives, that helps to delay the absorption of the insulin and adjust the pH level to avoid reactions with the injection site. Found in the pancreas in the form of beta cells, it triggers the cells to be able to accept the glucose from the food to make adenosine triphosphate, or ATP, simply known as energy. Insulin and the body. When engaging in physical activity, the body's temperature goes up, which by one of the solubility rules increases solubility when temperature increases. Since the body's temperature increases, it allows the glucose to become more soluble and be used up, which results in the patient requiring food, therefore requiring insulin. Another solubility rule is the increase of surface area increases solubility. For a diabetic patient, the insulin in liquid form allows it to be easily dissolved into the bloodstream at the rate at which the patient needs it to last. There are 4 different types of insulin available: rapid-acting, short-acting, intermediate-acting, and long-term acting insulin that can last anywhere from 15 minutes up to 24 hours long. In order for a diabetic patient to calculate just how much insulin is needed, it is all about the grams of carbohydrates is in their meal. Using stoichiometry, patients can figure out how much of a dosage is needed while using the conversion factor of 1 unit of insulin for every 10 grams of carbohydrates. Let's take a look at a graph that shows the blood glucose concentration Y over time X. As you can see, the sweet spot for blood pressure is marked off by the white dotted lines that should be somewhere between 70 and 120. As shown by the white arrow, when you eat, your blood pressure goes up, and as shown by the pink arrow, which represents insulin, your body releases it, which causes your blood pressure to go back down, and the cycle continues. When you eat, the beta cells, or insulin, are naturally released into the bloodstream. When the food is digested, this production of the insulin increases.